Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve a question from mechanics, and the question we are going to solve belongs to paper 9709/42 for the session May June 24. Let's go through question number 5 of the paper. A particle of mass zero point 0.8 kg lies on a rough plane which is inclined at an angle of 28 degree to the horizontal. The particle is kept in equilibrium by a force of magnitude T Newton. This force acts at an angle of 35 degree above the line of greatest slope of the plane. See the diagram. The coefficient of friction between the particle and the plane is zero point 0.2. Find the least and greatest possible values of T. Very interesting. One of the most important questions of mechanics. Well, let's start the solution little by little. We cannot solve whole of the solution at one step. So look at this. First, what should we do? In the first step, actually, we will have to find out the normal reaction force, because look at this. The plane is not smooth at all. It's a rough plane. Okay. So whenever we are given any rough plane, first of all, we will have to find the normal reaction. Then for normal reaction, we will have to just sketch out the figure. Let's say this one is the normal line. Okay, and this is weight always acts straight downward. This is weight. Okay, then this is our angle, which is 28 degree. 28 degree. Well, and this is a 90-degree right angle triangle. Well, and there is one more triangle we can draw over here, which is this one. Okay, so now we will have to find the normal reaction. First of all, normal reaction normal reaction force is actually the net force, resultant force of vertically upward and downward forces. So we will calculate R plus upward force. What are the upward force? Upward force is over here. This one is upward force. In this case, this one is one of the upward forces, and the other one is upward force, means above the particle. Here is our particle. Look, particle is over here. Okay, so the force acting upward on that particle is this, along this line. This is the magnitude, and the other upward force which is above the particle is this one, caused by tension. Okay, so R plus the upward force is T. For vertical line we use sine 35. Sine 35 degree angle is 35, equal to, as we are finding the resultant force of normal reaction, 35. Let me write it more appropriately. 35 degree is equal to downward force. What is the downward force? Downward force is nothing but the weight. So weight is, mg cos, what is the weight we calculate? Mg cos, how much is the angle? 28 degree. 28 degree. So this is our normal reaction. Then finally we will get R is equal to mg. M is the mass of the particle. Mass of the particle is 0.8. So 0.8 into acceleration due to gravity is 10. So this is 8. 8 cos 28, cos 28. And then minus from the left side there will be t sine 35. T sine 35. So this is our normal reaction. So we have already obtained our normal reaction force. Well, now the next step of the solution. What will be the next step of the solution? Then the most important part of this solution is to understand what the least as well as greatest possible values of t. What does it actually mean? So let us analyze the scenario. Suppose this is the plane. Okay, here is the particle. Here is the particle. Now particle by nature, due to acceleration, due to gravity, it is about to move down, definitely. So the particle is about to move down, where due to what? Due to weight. Only weight is trying to slide the particle move down, whereas rest of the forces are acting as resistance force. So this is what the first scenario is. Look at this. We are going to differentiate and identify the least and greatest possible values. So what does least and greatest possible value means? Once again, I'm repeating. Here is the particle is lying at this point, and it is by nature or due to the acceleration, due to gravity, it is supposed to slide down. So weight is the only driving force which is causing sliding it downward, and rest of the forces, all other forces, including this t, including this tension, or including this external force, all other forces is causing resistance to motion. So for the least value means external force which is applied on the particle is one of the resistance forces. I think you are getting my point, that for the least value of t, t is external force which is one of the resistance forces, not only resistance force. This is one of the resistance forces. That's why it is least in magnitude. And the scenario is actually the particle is about to move down due to weight. Weight is a force in this case. Well, the second scenario is, here is the particle. Well, now all the forces are trying to move it downward, but only one force, the force, external force alone, the external force alone trying to move it up. External force is the only driving force which is trying to move it, slide it upward, and rest of the forces are acting as, all other forces are acting as resistance to the motion. So what is the difference? In case of least value, the external force is one of the resistance forces. That's why, as this is one of the forces, so it has least magnitude. And in the second case, external force is the only driving force which is moving the particle upward, and rest all other forces are trying to slide it downwards, acting as resistance force. So for the least value, tension is, I mean, external force is one of the resistance forces, and for greatest possible value, for greatest value or maximum value, tension is the only driving force, and rest of the forces are causing resistance to motion. So one after the other, let us solve this. Let me write over here. And for such cases, we are going to apply the motion law, concept of the motion law of Newton. So what is the concept of the motion law of Newton? Before that, we should write when the particle, for the least value. Okay, first we are calculating the least value. When the particle, when the particle is about to about to is about to is about to slide down, slide down. When the particle, we have already explained that when the particle is about to slide down, then tension will have the least magnitude, down. Okay. Well, when the particle is about to slide down, here is the particle. So if particle slides down, then what is the force, driving force here? Let us write driving force minus resistance force is equal to mass into acceleration. We know the concept of the motion law of Newton. Now, what is the driving force? We have already explained that driving force is nothing but the weight. This weight is causing the particle slide down. So, what is the weight? Weight is mg. mg sine, this is actually, this is parallel to, let me show the figure more accurately. It is, if you can, yes, if I erase this, then you can understand it better. Look, well, so this is just, yes, this is the way the particle may slide down, and weight is causing this. Weight is, yes, this is the way. So our 90-degree is over here. Okay, let me erase once again. Yes, so this is our 90-degree. Well, then the particle is about to slide down. That means the force along this, which is caused due to weight. So mg for this vertical line, in terms of this triangle, it is actually vertical line. This is vertical line. That means parallel to the plane, yes, this way it is sliding down, and only weight is causing it moving down. Mg sine theta, mg sine theta, sine, how much is the theta? Theta is actually 28, 28. And we have already explained the rest of the forces are causing resistance to motion. So what are the rest of the forces? One is normal reaction, because the surface is rough, so normal reaction is mu r. What is the resistance force for a on a rough plane? And the other resistance force is nothing but the tension, I mean the external force. So that is T, and this way, this is our direction, so this is horizontal. T cos 35 degree, cos 35 degree equal to mass into acceleration. Actually, as the particle is in equilibrium state, system is in equilibrium, so there is no acceleration at all, hence the right side is 0. Now we are going to substitute the value we do have so long. First of all, mass of the particle is zero point 0.8, so zero point 0.8 into 10 into sine 28, sine 28 minus mu. Mu is the frictional coefficient which is given by them, it is zero point 0.2. So zero point 0.2, and R, we have already calculated the normal reaction. R is 8 cos 28 minus 28 degree minus T sine 35, T sine 35 degree. Well, this is what our step is now, sine 35 degree. Well, so ultimately what is it going to be? It is going to be 8 sine 28, 8 sine 28, 28 degree minus, if we multiply by zero point 0.2, it is going to be 1.6, 1.6 cos 28 minus minus plus zero point 0.2, zero point 0.2 sine 35, zero point 0.2 sine 35 equal to 0. Sorry, we skipped one of the terms, so we skipped this one, so this should be written minus t, minus t cos 35, minus t cos 35 equal to, right side is 0. Well, let us calculate now. If we calculate, what is it going to be? Here there is something to be added more, which is minus t cos 35, t cos 35 degree equal to 0. Well, if we isolate T as our T is our subject to be made. So let us make T as our subject. Well, if we take T as common, then what is it going to be? 0.2t. Here this will be 0.2t. Yes. So if T is taken as common, first one is 0.2 sine 35, sine 35 degree, sine 35 degree, sine 35 degree minus cos 35 degree, cos 35 degree, and if we transpose this to the right side, it is going to be 8 sine 28, 8 sine 28 degree, then plus 1.6, 1.6 cos 28, 1.6 cos 28, cos 28 degree. Then it is time to isolate T. If we isolate T, what is it going to be? Or T is equal to, the numerator is 8 sine, let me write over here, 8 sine 28, 8 sine 28 plus 1.6 cos 28 degree over zero point 0.2 sine 35 minus cos 35 degree. Okay, hence it is going to be, let me calculate this using my calculator. It is 1.6 cos 28 plus, yes, we made one more mistake. It is actually from left side. If we transpose this, it must have negative symbol. So this is actually negative 8. Let me erase this. It is going to be negative 8 sine 28. Negative 8. So let us write negative 8 sine 28. So hence the symbol, this is negative. So if we calculate, that is minus 8 sine 28 plus 1.6 cos 28 over zero point 0.2 sine 35 minus cos 35 equal to 3.3, 3.3, 3.32. Hence our T minimum. Okay, T is minimum, means least value of T. T is T minimum is how much? 3.3. 3.3 Newton, already in symbol has already been given. So how much is the 3.33? It was 6. Okay, so it is going to be 3.33. So how did we calculate this? I think you have understood so long, as I have told. So there are two cases. One is least value. Least value means external force is one of the resistance forces. Simply you will just remember this, that for least value, the particle is about to slide down and only weight is the driving force, whereas the external force is one of the resistance forces which causes resistance to motion. That's why in this case, as T is one of the forces, that's why T is minimum in this case. Simply you just remember, the least case of tension, the particle is about to slide down. So let us see the second case. What will be the maximum value of T? For that, if I show you, let me write just under this whether I do have space or not. Okay, I will have to borrow a page. Okay, let's write on the next page. This may be our next page. So here if you write, well, for the second case, we have already analyzed that the particle was about to move up. So let it be written. We will write, let me write on the next page. And before that, we will write the normal reaction force. This is our normal reaction force, which is r equal to 8 cos 28 minus t sin 35. Okay, so r is equal to, our normal reaction is r equal to, what is it? No, let me write just. Okay, r is equal to, what is it? R equal to 8 cos 28 minus t sin 35. T sin 35. Sin 35. T sin 35 degree. Sin 35 degree. Well, this is our normal reaction force. Now we are going to calculate the maximum value of tension. So we have already analyzed that particle was about to moved up, slide up by the external force. External force is here what? T. This is the external force which is trying to move it up. Okay, so how will we write the, let it be written, when the particle is particle is particle is particle is about to about to about to move up, slide up or move up, whatever you write, slide upward, slide up. Okay, when the particle is trying to slide up due to the external force, so we will write driving force. The same concept we are going to apply. Driving force minus resistance force is equal to mass into acceleration, and driving force is nothing but the external force we have already calculated, which is t what? Cos, how much is the angle? It's 35. Cos 35 degree minus, all of the forces are causing resistance. So first resistance force is what? That is weight. Weight is mg, sine, how much? Sine 28 degree, sine 28 degree. Then the rest of the force is frictional force. What was the frictional force? Frictional force is nothing but mu r. We know it is mu r. Let us write minus mu r. Okay, mu r is equal to, right side must be 0 because the system is, the particle is kept in equilibrium. Well, so little by little, let's move on. So t cos 35, t cos 35 degree minus mg is actually mass of the particle is 0.8. So weight is going to be 8. 8 sine 28, 8 sine 28 minus mu is 2, and reaction for normal reaction force we have already written over here. How much is this? R is equal to cos 28 minus t sin 35. Cos 28 minus t sin 35, t sin 35 degree equal to 0. So let us simplify this. If we simplify, it is going to be t cos 35, t cos 35 minus 8 sin 28, 8 sin 28 minus point 0.2 cos 28 minus plus point 0.2 sin point 0.2 t sin 35, sin 35 degree, sin 35 degree is equal to, sin 35 degree is equal to 0. So let me zoom it in again. Yes. So what is it going to be now? It is going to be, if we isolate t as subject, So T is cos 35 degree. Then another one is plus point 0.2 sine 35 degree, sine 35 degree equal to, in the right side there will be 8 sine 28, 8 sine 28 degree plus point 0.2 cos 28 degree, cos 28 degree, 28 degree. Well, then if we isolate T, and this is the maximum value, we have already decided that this is the maximum tension in the string is. So our numerator is going to be cos 8 sine 28, 8 sine 28 degree plus point 2 cos 28, cos 28 degree, cos 28 degree will be divided by cos 35, cos 35 degree plus point 0.2 sine 35 degree, sine 35 degree. Then it is going to be, let me calculate this using my calculator. T 8 sine 28 plus point 0.2 cos 28, will it be point 0.2 cos 28? Sorry, I made a great mistake. Our normal reaction was, it was 8 cos 28. It is not cos 28. It was 8 cos 28. Let me show you again. It is 8 cos 28. Look at this. This is 8 cos 28 minus t sine 35. So it is 8 cos 28. Wherever we have written cos 28, it is going to be 8 cos 28. It is 8. So 8 and point 2, it is going to be 1.6. It is not point 2, it is going to be 1.6. 1.6 cos 28. After that, it is not only point 2 cos 28, it is going to be 1.6. 1.6. Yes, it is 1.6 cos 28. In the next step, it is going to be, so if we calculate it, finally we will get 8 sine 28 plus 1.6 cos 28 over cos 35 plus point 0.2 sine 35 equal to 5.53. 5.53. This is the maximum force acting in the string. Hence, T is equal to T maximum. T maximum is going to be 5.53 Newton. I think you have understood. So for the first case, for the last moment, again I am explaining. There are two cases. In one case, the particle was about to slide down when all the forces except weight is the only driving force which is trying to slide the particle down. That's why weight was the only driving force, and rest of the forces including the tension or external force, rest of the forces are causing resistance to motion. That's why rest of the forces have been subtracted. Look at this, rest of the forces, all the forces have been subtracted from the driving force. Driving force is nothing but weight. But in the next case, when T was maximum, driving force was nothing but external force, only the external force. Look, only the external force is the driving force, and rest of the forces is actually resistance to motion. That means resistance force. And thus we got that the minimum force acting in the tension or in the string, the minimum force is 3.33 Newton, whereas the maximum force acting in the string is 5.53. And first of all, whenever we solve such question, this is very common in mechanics. Remember, first of all, we will find the normal reaction force before starting our main part of the solution. We find the normal reaction force, and normal reaction force is nothing but the resultant force of vertically upward and downward forces. That means net forces of vertical line, net force that acts along vertical line. That means difference between the upward and downward forces, vertically upward and downward forces, is the normal reaction. So thank you all for watching the video, and in the next video inshallah we will prepare one more solution. Allah Hafiz. Let me show the second one as well. This is the second one. Fi amanillah.